Okay, L'Hopital's rule. Okay, so this is going to be very, very useful. So this is basically another sort of a shortcut to evaluate limits. Okay. So let's f of x and g of x be differentiable functions. Okay. So if f of a over g of a is equal to 0 over 0 or infinity over infinity. Okay, so if you get one of these two indeterminate forms, okay, like we know what an undeterminate form is, we did it at the beginning of the course, then, and here it goes, this is the beauty of it, the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x over g prime of x. Okay, so let's do a few examples on applying this. So evaluate first limit as x approaches, let's start with a very easy one. So 2 let's say x2 minus 4 over x minus 2. Okay, it's a very, very easy limit, right? We know we did it at the beginning of the course. That's probably the first limit I told you, the first exercise I gave you in the course was to evaluate this limit. And I hope that you're okay with this now. What would you do? You would factor, right? You would factor the top. You check that it's 0 over 0. Then you factor the top and cross out the x minus 2's. Remember this? Okay, so let's use L'Hopital's rule instead. Okay, so of course, if you first thing you do, you plug in 2, you get 0 over 0. And so since I have 0 over 0, I could use L'Hopital's rule. So I'm going to write equals, and I'm going to put a little h here to show that I'm using L'Hopital's rule. Okay, so limit as x approaches to 2, and I'm going to find the derivative of the top, which is 2x, divided by the derivative of the bottom, which is 1. You with me? And now I evaluate this limit. That's easy. You plug in 2, you get 4. And my answer is 4. That's not bad. Not bad at all. Another one. Number 2. limit as x approaches 0 of sine x over x. You remember what that is?
One.
What was that? What?
1.
1. I think we did enough of these. And we proved it using the squeeze theorem, which took us about a page to do. Okay, so if you plug in 0 here, you get sine of 0 is 0 over 0. So I could use L'Hopital's rule. So its limit as x approaches 0, the derivative of sine is cos, and the derivative of x is 1. And now you plug in 0 in here. Cos of 0 is 1 over 1 is 1. Took us one line. Okay, that's pretty good now. So some of you during the midterm exam, you use L'Hopital's rule, but I haven't shown it to you, so so I can't, I couldn't accept. Okay, now I'll be able to accept. For the final, you'll be able to use L'Hopital's rule whenever you want. Okay, so let me give you 1 or 2 examples to try. Easy ones first, and then more complicated ones. First of all, any questions? So I have a question. How do you know if a function is differentiable? Okay, so the you have to check if there is no problem in the derivative. If there's no problem in the function, in the slope of the function. Okay, if there's no place, like for example, an absolute value, there's a problem. Okay. Anyways, I'm going to talk about differentiability when we do curve sketching. Okay, let me just exercise on L'Hopital's rule. Okay, here's some. So try three. Limit as x approaches 0 of sine x minus x over tangent x minus x. Okay, try it out. Always verify if you're allowed to use L'Hopital's rule by plugging it in. Okay, don't forget that. So the first thing I do, I replace 0 inside. Sine of 0 is 0, minus 0 is 0. Tangent of 0 is 0, minus 0 is 0. I could do L'Hopital's rule. Equals L'Hopital H limit x x approaches 0, and I'm going to derive the top. So I get cos of x minus 1 over the derivative of tangent is secant squared x minus 1. All good? And then I replace again the 0 inside. Cos of 0 is 1, minus 1 is 0. And on the bottom, secant is 1 over cos. So that would be 1 minus 1 is 0 again. Oh, there you go. So I have to do L'Hopital's rule again. Okay, at this point, I could actually simplify things, but let's say I didn't see it. So I'm going to do L'Hopital's rule again. Or actually, secant squared minus 1 is equal to tangent squared. Oh, no. It's 1 minus tangent squared. Okay, so forget this. So it's limit, it's negative tangent squared, sorry. So x approaches 0. So derivative of top is negative sine x. And the derivative of the bottom, it's 2 secant x times the derivative of secant, which is secant x tangent x. Are you okay with this? Okay, so I did the derivative of secant squared is 2 times secant times the derivative of secant, which is secant squared, secant x tangent x. Let me know if it's not clear. I'm going to continue here. Equals. So now I'm not going to do L'Hopital's rule anymore. I'm just going to try to simplify what I can here. Limit x approaches 0 of negative sine x over, and on the bottom I have 2 times, so secant squared is 1 over cos squared, times tangent is sine x over cos x. And so I could cross out the sine x's. Okay, and then replace the 1 inside, the 0 inside, sorry. So I get on top negative 1, and on the bottom I have 2 times cos of 0, cos of 0, cos of 0, which is 1, so it's 1/2, negative 1/2. That's my answer. At the end, some of you got it right. Good? So here, that's a tricky one. We had to do L'Hopital's rule twice. Because after one L'Hopital's rule, we ended up again with the same undetermined form, 0 over 0. Good? Questions?
So we keep on doing like this rule till it's not 0 on 0.
Yeah, hopefully it would work. Every time it would work. Sometimes you're going to go in circles, as you'll see. I mean, I don't know if you're ready for a hard one. I can give you a hard one now, or would you like one at the same level about? What do you think?
Can we try one at the same level first?
Of course. So let's try one at about the same level. Let me see. Let's try this. So it was number 3, I think. Yeah, so number 4. Limit as x approaches to infinity of, let's say, ln x over x. That's pretty easy. So I replace infinity here. Ln of infinity is infinity over infinity. I could use L'Hopital's rule right away. Limit as x approaches infinity. The derivative of ln x is 1 over x divided by derivative of x is 1. So 1 over infinity is 0. That's it. It's as easy as that. Okay, I don't know how you would have done it otherwise. How would you evaluate this limit? I don't know. Okay, so pretty much have to do L'Hopital's rule to evaluate this. So let's do a more complicated one. Okay, so last one for today.
Sure.
Yeah.
Aren't we supposed to do like 1 over x times x minus ln x?
Oh, the quotient rule?
Yeah.
No, no quotient rule. It's derivative of top divided by derivative of bottom. That's L'Hopital's rule. I'm not evaluating the derivative of this function. I'm evaluating the limit of this function. Not the same thing. Okay? Okay, so let's try a harder one. x approaches 0, so e power x minus e to the minus x minus 2 sine x over x times sine x. Okay, so this one's a bit nastier. Push up here. Okay, go for it. So I plug in 0. So e to the 0 is 1, e to the 0 is 1, 1 minus 1 is 0, sine is 0, out, 0 times 0 is 0. L'Hopital's rule is in effect. X approaches 0, the derivative of the top, e to the x plus e to the minus x minus 2 cos x over the bottom. I have a product rule, so I have sine x plus x cos x. You get this? Any questions here? Okay, guys, when I answer you in the chat and I say I write y, it doesn't mean why because why did you get it, but y means yes. Okay, I'm too lazy to write yes and no and yes and no and yes, so y and n. Okay, so because a few people asking me are justifying when I say why and they got the right answer and you're justifying the answer. Okay. So I put 0 here now, so I get 1 plus 1 is 2 minus 2, I get 0 again. And on the bottom, I get 0 plus 0, I get 0 again. And so I have to do L'Hopital's rule again.
Wait, sir, why is it sine x plus x cos x?
The bottom?
Yeah.
Because it's a product rule. Derivative
Okay.
of x is 1, right? It's 1 times sine x plus x times cos x. Good?
Yeah.
Okay. And then I derive again. So it's e to the x minus e to the minus x, and then plus the derivative. So it's 2 sine x. And on the bottom, I have cos x. And here I have the product rule again. Cos x minus x sine x. Good? Questions? Okay, 1 minus 1 is 0, plus 2 times 0, again 0. And on the bottom, I have 1 plus 1 is 2 minus 0 is 2. Oh, there you go. 0 over 2, and that's a 0. My answer is 0. Okay, so L'Hopital's rule once, twice. 0 over 0, 0 over 0, 0 over 2. The answer is 0.